I'm currently the data engineering tech lead at a company called LendUp. So what do we do? Our headquarters is literally just a few blocks away. We're a mission-driven company. Our mission is to provide anyone with a path to better financial health. We build technology, credit products, and also educational experience for majority of American population that we consider as underserved, mostly because they have either poor credit or they have really volatile incomes. So we're in this space trying to help them to get a better financial health. Like you probably saw the title, it's called a Scale Data Platform at LendUp. I actually took away a few keywords in the title because I had a feeling that that will push a few people away. So what do we actually be talking about today? Scale enterprise data platform at LendUp, or fintech in general. So I know, what do you think? Like here's a startup central. Like what are you talking about? Why enterprise? Enterprise is bad. Enterprise is anti-pattern is only useful for very large organizations. So, but through this talk, I want to share some of our experience through the years and of how we learn to adopt some of the core concepts and then guiding principle from enterprise data platform, and then use that to build our own data platform, and then be able to scale that over the years. So first is like I want to kind of talk about like the data landscape and also the unique challenges we have today. On the left side of the screen, you will see like a representation of the different domain of data that we have at LendUp, and it's also pretty representative in most of the financial lending business as well. So I put different kind of data domains on two different dimensions: is low versus high volumes and structured versus unstructured data, because if like basically those two dimensions will determine what your tech stack looks like, right? So you can tell like it's a pretty large surface area. So how we manage this at LendUp? So there are like a few unique challenges here. First and foremost is the cost and the complexity of managing and localizing third-party data. So this is like a common challenge at a fintech company, because we heavily rely on third-party data for user acquisition, risk analysis, underwriting, fraud detection, customer retention, etc. So there's a lot of surface area there. And in fact, I did a quick count, and then by volume, we have over 36% of the data in our data warehouse is actually from third-party data. So when you consume this much like third-party data, you really have no control over the schema, the throughput of all the different kind of data, right? So and then how you are managing them and localizing them so that your business partners can use the data is very challenging. Secondly, building a sustainable data platform is hard. I struck out like the word scalable. It doesn't mean it's easy to build a scalable data platform nowadays. It's just like over the years of the evolution of the data engineering system and tools, storage and computation becoming cheaper and easier. However, how you piece together everything together, and then making sure the whole business stakeholders can use the data that you produce and maintain still remain to be challenging. Number three is who actually own the data, right? So I think this is like a challenge that we have. Like even today, we still have this kind of challenges at LendUp. Is who actually owns the data? Is the developer who write the applications that produce the data owns the semantics of the data, or is actually your business partners? Number four is around the unified views on the data across your organization versus a self-serving multi-tenant data platform. Sometimes they have conflict of interest. So through the talk, I quite want to share how we kind of tackle those like challenges over the years. So here is what the data organization looks like at LendUp. So we have two main functions. One is called data platform, another is data servicing. So data platform, we're responsible for 4 different components. Data movement, those are all the traditional ETL tools, data injections, transformations, and then we have data quality. That is how you ensure the business level agreements. We also have data security. That goes without saying, that's highest priority at LendUp. And then data discovery. By the way, I do want to mention that a few announcements today from AWS is really exciting around data security, and I'm actually reading through some of the blog posts and then trying to see if we can incorporate that, and the data discovery as well. And then on the data servicing team, those are our data service engineers or data analysts that work with our different domain of data, work with our business stakeholders, and they want very accurate and accessible data, and they want to be productive as well. So I mentioned that like through the years we learned to adopt some of the core concepts of enterprise-ish program. So here are a few keywords like discipline, ownership, immutability, discover, and then multi-tenant. So what that means and how did we get there? Through the years, in the past 5 years, I would say we kind of went through 3 different iterations to get to like the point that we have today. And through each iterations, we start to bring in new technologies and a new AWS infrastructure that help us to optimize time to market, time to value, and then help us to scale our data platform. First, I'll start with our good old friend Bash, right? As like when we started the company, our ETL system is literally a collection of Bash scripts that manage a lot of SQL scripts, and that was managed by cron. And we actually have a name for that project. It's called a Sisyphus, right? So it's literally the great god that just repeatedly every day that just move the data around and every day in the morning start over again. So it's really a Postgres-based data lake. And so what that means is like all of our transactional data. I saw like a few of you guys are laughing, so I'm pretty sure that you have been through there as well, right? We have all been there. So like it's really like we expose all the OLTP data, and then we have data consumers literally just like build like OLAP data on top of the transactional data, however they want. So like the problem is very obvious, right? So it's a very slow time to value, and you have very poor support for ad hoc analysis, and there's like zero knowledge on what data you have there and available for the data consumers. And what happened was people spend more time finding the relevant information instead of like using it to gain the insights. So we quickly move on from this iteration, and that's to the second stage where we introduce like a critical piece of our infrastructure with Airflow and Redshift. So we were the very early adopter of Airflow, and our engineering team also contributed back to this open source project as well. So if you haven't heard of it, it's open source by Airbnb, and right now is also part of the Apache Foundation as well. It's a workflow management system, and there are a few things that we really like about it, so that we start to use it at a very early stage. So a few things really kind of like stood out. Number one is like you can define your workflow as code. That's like really powerful, right? Like there are like basically two ways you can do workflow management. You either just like write code implicitly saying this depends on that, your text B depends on text A, and then you like if text A failed, and then you have to manage retries or alert all by yourself, or you define everything explicitly in a graph, right? So that's where like Airflow came in. So you can write your logic, your workflow as code, and then you can specify your tags and dependencies programmatically. So we introduced this very early stage, and it also has a very powerful UI for data ops. And then we also replaced Postgres with Redshift. I think over the years, if like you ask me like one thing that I feel like one of the technical decisions that I think that we did right was introducing Redshift, and we start to use Redshift as our centralized data warehouse. There are a lot of talks about like why Redshift is good, is performant, so I will skip that. But there are a few things like we started to use is one is we have isolated schema as a data landing zone. What that means is we have a separate schema that all the data we ingest like land in that schema first, and that's not exposed exposed to anyone but data platform engineer. And then we do a bunch of like checks, and if everything passes, and then we move to a different kind of other schemas. And then all the tables are accessible by views instead of the materialized table, because very often you need to partition your data, you need to do some migration. So by having a view in front of it, you can do all the transformation or migrations behind the scene, and your business users won't be affected. And we use Flyway for schema evolution, just as our OLTP database. One thing I mentioned is that we use copy via SSH. What that means is you can actually build up a SSH tunnel that via a remote host, like you stream your data from your source database, in this case Postgres, directly to Redshift. So that's what we did at this stage, and that ended up causing a lot of problems. So what are they? So first is like your ETL job and then data ingestions, constantly fighting over resources with your business users. And because we stream the data directly, and we can't really do much like optimization on compress the data or split the data into multiple chunks so that you can leverage like parallelism, right? So but it was simple. It was easy to set up. But then we have this like resources issues. And secondly, because we stream the data directly, so we kind of like give 100% trust on the upstream system, saying like, hey, we believe every data that we take from you. And if you're working the data, you know, like you can't literally trust nobody. So and that ended up like causing a lot of problem, because if the upstream changed their semantics or schema, that broke the data ingestion process all the time. Third is like our business team or our compliance team always ask questions like, hey, what our system looks like for a specific user at a given time. It ended up to be like actually pretty hard question to answer. Why is that? Because your upstream system, you can't really ensure immutability. A good example, let's say a user's table, right? And then you might have like one row per user, and then you modify that all the time. So how do you ensure that immutability of that? So you have to do that in the data layer. So this is how we kind of migrate to the third iteration of our data platform, that we highlighted a few things: immutability, data quality, data discoverability. So the first thing that we did was we moved away from Redshift being the data landing zone. We centralized using S3 as the landing zone, or you can call it data lake. But we took a hybrid approach. The reason that we used like S3 as the centralized landing zone was because then we can heavily optimize the loading process. We start to kind of like split the data into different chunks, and each chunk of the data we make sure is around like 100 megabyte to 1 gigabyte ish. And that's like what we figure out like the best kind of size for loading in Redshift. And then we can also leverage some of the new tools coming out from AWS, Redshift Spectrum, and also AWS Glue, which was announced last year at the reInvent. And then they all have seamless integration with data in S3. Number three, which is like the most critical piece for us, is enforce immutability in the data layer. Like there are like two guiding principles that we adopted, and you'll be shocked that those are when I talk to other folks from different companies, like small to large organization, I realized those guiding principles actually is part of like some of the enterprise data program almost like 2 decades ago, and we're still kind of like learning that, and I thought that was like something cool. And then number one is like never delete. We never delete any data when we bring that into S3. And when we do have to update a specific partition or specific data, we always archive the previous partition before we update the new one. And then we start to kind of collect a lot more metadata, and then have the metadata sitting next to your partition. Including the manifest file for Redshift loading, or like some of the metadata that you use when you extract the data or load the data. We have all the metadata literally sitting next to the partition, so that you can always know what happened at a specific given time. So here is like how we design our data landing zone. So here, like it kind of like represent like two processes. Like so, the first round is we have an entity called a user, so we have a partition by hour, and then we have two prefix in S3. By the way, those are all in S3. One prefix is called data. You have a batch ID, which is just timestamp when we finish like the ingestion, and then we have a metadata. One is around the metadata of the data extraction. Another is the actual manifest that used for loading data into Redshift. So what happened if you realize like the user's ETL for this specific partition is actually wrong? We need to fix it. So you have to run the ETL again. And instead of like updating the current partition, what we did was it's almost like two-stage commit. The first stage is we move all the previous partition into archive, and then we don't delete the metadata. Then we recreate like the data prefix, and then start to kind of like write the new partition. So by doing this, like we never delete, and also by doing this, you make sure that you always have a copy of the data no matter like what happened. And then we have like a really simple API, just like to tell me what is the data that you can actually trust. And of course, that always just like point to the data in the data prefix. Second thing that we started to do was really took data quality as first-class citizen. And the reason we did that was because we have found that through the years that like data quality and data ownership really go hand in hand. And we have this in-house system called a checkup. And like on the left side is a diagram of how checkup works. And you can tell like we kind of got some heavily inspired from some medical terms. So typically what happened was we collect some of the stats around a specific data. So for instance, like let's keep using the user's entity. What we did was we would collect some of the data around like what is the amount, like the minimum, maximum, and how many times the amount column is null. And then once we collect all this, we run the diagnosis. And then in the diagnosis, those are all the business rules. Those are we encourage our business team or data analysts or data service team to actually tell us what are the business rules. So for instance, like amount has to be greater than 0. It cannot be more than $5,000. So if you saw someone purchase an ice cream that is like $5,000, you know something is wrong. And also it cannot be null. And then once you have all the diagnosis, you can you have your prescription, right? So like based on some kind of like threshold, you say okay, it's passed, and then you let the data flow through. Or you have like error or warning. You hook to like emails or PagerDuty that you have the data producer to be responsible for fixing the data to improve the data quality, and everything is defined in a YAML-based spec. And we have a very tight integration with Airflow. So in our data ETL, like we will have those kind of little checkup tags like all the time, and then they have a different color as well, so that you know like where the problem is. So which is pretty nice. And then the way it works is like we have the data consumers. They will define the business level agreement, and then we have the producers. They're responsible for enforcing that. So here is so this is what I mean by data quality and data ownership, which is in this case like everything here, like the amount needs to be more than 0, needs to be less than $5,000. Those are all the contract as a data producer that you sign the contract with your data consumer, and as an engineer, like our job is to make sure whatever we do, whatever changes we made in the upstream system, the contract is not broken. And this goes back to one of the values we have at LendUp, which is acting like an owner. So we really want everybody to act like an owner of the data quality, and then making sure that like the business team spend more time to kind of for analytics instead of like worrying about is my data stale, is my data accurate, can I trust it? next, I want to kind of like talk about a few things that we did around multi-tenancy, especially in the context of Redshift. So Redshift is shared resources. There are like two ways that you can make it super scalable. One is you throw money at the problem. You have like a huge cluster, and then like the memory never got like filled up, and everybody's happy. Or you do something that we went through. We went through a lot of pain, and we learned over the years how to optimize Redshift as a shared resources for multi-tenancy. So the first thing that we did was we introduced this thing called LendUp YAML, so which is a YAML spec, but is more strict, more structured than that. And what that does is literally we make it a header for every single SQL script that we have in our system. So this header is embedded, and then we have all the system, including checkup, including Airflow, will interpret this header and understand what needs to be done, how we can programmatically construct the DAG, and how can we make sure we programmatically call checkup to ensure the data quality. And you can use this for profiling as well. Here's a quick example of what the header looks like. So for instance, you have what is the priority weight of this SQL. If it's super high, that means you should run this like earlier than anybody else. And then you have you define SLA, you define timeout, and what are the dependencies. So everything is written in a spec that everybody understand. And then here with Airflow, you also achieve the data lineage. Second thing that we did was we made sure that we have a dedicated schema for each tenant. Tenant here usually align with your business organizations. So for instance, like in our case, we have different product engineering teams. We have loans team, car team, and we also have different kind of business function teams like finance team, growth team. So we have a dedicated schema for each tenant, so that one is we're able to kind of like really look at like profiling all the different queries and figure out where the performance bottleneck is, and also is really for compliance and the security. Last but not least, like one thing that we also introduced at a very early stage is to leverage like the WLM, workload management. That saves a lot of trouble for us. And basically, it's a wipe. You can go to like AWS console and then define all the different workload management rules. But also you can use their CLI to so that you can sync with something like GitHub with your rules. And there are a lot of like tutorials out there talking about how to optimize this. Here, what I really want to talk about is some like lesson we learned of how to not using it. First and foremost is like you don't want to define actually too many queues. When this first came out, and one thing that we did was, oh, you know what? We have schema lined up with the tenant. Why not we also have the queues lined up with each schema and the tenant as well, so that you have really like a fine control over the workload. And what happened is, if you are not actually, like if one of the tenant is actually not actively using Redshift, and then that's become like idle resources. So you don't want that. So what we, like after a few iterations, what we end up with was two queues. One is just for ETL jobs, and those are all the kind of like daily scheduled jobs, including critical business reportings. And also another queue is around BI tools or ad hoc queries. So those are all the things that sometimes like unexpected, heavy, expensive query can happen, and then so you can isolate that into a separate queue. And also, once you have this, like AWS introduced this WM query monitoring rules. I believe a year and a half ago. Those are really important as well. So what we did was we defined a few rules based on some of the data profiling that we learned over the years. And then, for instance, like if it's an ad hoc query, here's a quick example of what the rule could look like. And for ad hoc query, you can say if its execution time is too long, consume too much CPU, and you are writing too much into the disk, then we should either log it so that we can grab the events later on and then analyze why that happened, or you can even abort it so that like that query will just literally once it hit the limit, it will just like abort. And to really understand like the Redshift in a multi-tenant fashion, you need a lot of like metrics. So we spend a lot of time on monitoring and alerting in Redshift. We have basically two sources of data to look at. First one is all the STL data. So all the STL tables. So all the STL tables, they're generated from Redshift log actually. So there's a data retention problem there. So like highly recommend that you have ETL jobs that persist and archive that data often. But those valuable data will usually showcase some kind of like the performance characteristics of your Redshift cluster, so that you can look at it and understand for each of the tenant how they are using your resources. Second source of a metric is coming from CloudWatch. That's a no-brainer. I do want to call out for a pretty awesome project that actually open source by AWS is on GitHub. You can search for Redshift Advanced Monitoring. It's basically a Lambda function that you can define a set of queries, query from like STL tables, and then that will convert into CloudWatch metrics. So if you already have something set up, for instance, like CloudWatch pipe to something like Splunk or Small Logic, I highly recommend you set up that Lambda function, so that you have a unified view of all the metrics. The way that we did was we actually used Grafana to plot all of the metrics, and Grafana a few months ago they had the capability to actually use Postgres as a data source, so we're able to plot all the STL metrics directly instead of like writing to CloudWatch metrics. So we can extend that really fast. So on the right side here is a sample Grafana dashboard that we use to monitor Redshift, and there are a few key metrics we look at, and I highly recommend to look at as well. Number one is all the query time, and also really just break that down to 50 percentile or 99 percentile, so that you can look at all the different outliers. And also columns not compressed. Compression is super critical and important in Redshift because one, it will significantly improve your query performance, and also that will save a lot of money because Redshift is charged by data storage. Number three is monitor the long logs. Redshift as an analytics database is not uncommon that you have long logs, but really like keep an eye on some of the long running logs, and then making sure you clean them up. Query scans not sorted, right? This is if you have a sort key, distribution key, you want to look at the query that not leveraging those. The last one that we look at all the time is packets. So those are actually all the packets. So basically look at the throughput of your query and making sure that you don't have a query that has like really high traffic. Because what happened to Redshift was when you have a really expensive query, if it cannot fit into the memory, they will write to the disk. So that is also part of this metric, which is memory to disk. So when you have a really expensive query start to write to disk, you will notice your Redshift cluster start to fill up really quickly. So you should have WM rules saying like to capture those really expensive query, but also have metrics to keep an eye on it. So what do we have learned so far at LendUp? Number one is really optimize time to value. And as a data platform team, it's just like as a developer, when you make some changes, when you make a pull request, your job is now down when your pull request is in the release queue, right? Like your pull request is down when it's released to production, is start to be used by your applications. So same thing here, like as a data platform engineer, our job is now down when we just like bring the data into the data landing zone or data warehouse. We want to optimize the time to value, making sure from end to end, like the business user can use like the quality data without worrying about the accuracy and also the performance. Secondly, optimize for the 80% of the use case. That's why we have that header in SQL, because we have like Spark jobs, we have a lot of other tools for heavy lifting, but 80% of the use cases is really just like SQL. either you are using Hive, Presto, or Redshift. End of the day, it's all SQL. Is just like common language that both business teams and a data team can understand. So do something to optimize that. Like goes a long way. Third is like it has to be simple in order to be sustainable. I think that I kind of mentioned that a few times. Last is production readiness review. So when you have a SQL that you want to deploy that, very often you have the problems where it's just like broke all the time. And then we have a Jenkins-based production readiness review to make sure we capture some of the like errors before we deploy that. So I want to also quickly share what's next on our roadmap. We're doing POC on AWS Glue. We think that is a really awesome tool to replace some of the data ingestion that we have. Unified user access control. We want to leverage an open source project also from AWS called PJ Bouncer -RR that you can define your query rules. We're also working on a few like open source dashboards. So if you're using Grafana and you also want to look at Airflow, Redshift, stay tuned. We're planning to open source that soon. So thank you. Here's my contact information. And we're also hiring. Check out our career page. We're hiring data platform engineers and service engineers. So if you're interested in our social mission, talk to me. And thank you.